Hello, and welcome to the video portion for the Parameters Lab of ME123. Today, we're going to be picking up right where we left off, covering the second part of our series on sketching. When we were last dealing with sketches, it was all very crude, drawing lines to approximate lengths and eyeballing everything. Of course, if that was the limit of how we could define sketches in SolidWorks, it would not be nearly as popular of an engineering software as it actually is. So obviously we have more to cover. I'm going to be working in a new part file for my examples today, with my units set in the millimeters and all of my sketching done on the front plane. First off, we're going to introduce a new vocab term, fully defined. A sketch is fully defined when it can only be interpreted in one way based on the given rules and information. A good way to think about this is to pretend that you're describing a shape to someone over the phone. Let's consider a triangle. I'm going to call up my friend and ask them to draw a triangle. Unless we're really good friends, they're probably not going to draw the exact triangle that I was thinking about. So I'm going to need to give them more information. One good place to start is where the triangle is in our sketch. While sketching, SolidWorks turns whatever surface we're working on into an infinite sheet of graph paper. For the moment, the only thing that we have to reference is the origin. Let's tell SolidWorks that I want a triangle with one point on the origin. To do this, we're going to need to apply a geometric relation, our second big vocab word for today. Geometric relations are geometric rules that SolidWorks allows us to give our shapes, such as telling it that 2 points need to share the same coordinates or that 2 lines have to be parallel. In order to apply a geometric relation, we have to select the things that we want to relate. This can be done by holding down the Control key on the keyboard and left-clicking on the two things that we want. These can be sketch entities, edges, planes, or points. Here, I've selected one of the corners of our triangle and the origin. With that done, we can see that a new menu shows up on the left side of the screen with some options for us to explore. Up at the top, it shows us our selected entities, and below that, it shows us our existing relations. These should be empty for now. Continuing down, we can choose a relation. I'm going to select Coincident, which sets the two sketch entities to be in contact with each other. With that, we notice a few things. First, the coincident relation shows up in our existing relations box. Next, a small green box with the coincident symbol shows up next to the geometry that it's affecting. You may have seen similar boxes show up next to some of the sketch geometry that you've produced previously. SolidWorks likes to be helpful, so it often guesses that you might want certain relations while you're sketching, and it will often apply those automatically for you. Sometimes this is helpful, and it can save you from manually having to apply them later. Other times, it's not at all what you wanted. In order to delete an unwanted relation, you can double-click on the green box and select Delete from the menu over on the left side of the screen. While you are sketching, you can tell if a geometric relation will be added automatically by keeping an eye on your mouse cursor. As you approach a relation, a little yellow box occasionally shows up next to the cursor. If you activate the tool while the box is there, this relation will be automatically added to your sketch geometry. In addition, some of the sketch tools come with geometric relations built in, such as the rectangle tool, which automatically applies vertical and horizontal relations to the resulting geometry. Anyway, back to our task at hand, defining our triangle. Let's see. Now that we have our triangle located in space, we can start defining the triangle a little bit more. I want one of the sides connected to our origin to be flat, so let's select this edge here and see what we can do. With just the sketch line, we have 3 relations to choose from. Horizontal and vertical are the two that immediately come to mind, and they do exactly what they say on the tin. Horizontal forces the line to be horizontal with our current reference frame, in this case making it parallel to the x-axis, and vertical makes it parallel to the y-axis. The last relation that it shows us is the fixed relation. Fix just staples something into whatever position it's currently in. This is not helpful in describing our shape, and it doesn't really mean anything if you're describing it over the phone. For these reasons, using the fixed relation is considered poor design practice and should be avoided in this class. You should never use the fixed relation. There is always a better way. Anyway, once we apply our horizontal relation and deselect our edge by hitting the escape key, we can see that the line has changed from blue to black. This introduces SolidWorks' color scheme and visualization tricks. Blue entities are underdefined, meaning that they need more information before they can be considered fully defined. Black entities are fully defined, meaning that there is only one way that you can interpret them, with the given information. This also introduces a little quirk in SolidWorks. The line itself is fully defined, but we can still change the length of it by left-click dragging on the endpoint. This is because SolidWorks imagines the line as infinite, and then uses the endpoints to define where the line starts being shown and where it stops being shown. This has the side effect of also allowing us to use the coincident relation to connect a point onto the extension of a line. So even though the 2 bits of geometry aren't actually touching, This endpoint of this edge here has to follow the line where it would be, as we can see via the dashed line. Let's consider what else we need to do to fully define our triangle. I want this to be a right triangle, so we're going to need to apply a perpendicular relation between two edges. I'm going to pick the two that we haven't used yet over here, but this time we see that we have a decent number more relations to work with. Collinear forces the two lines to live along the same infinite line. Perpendicular forces the two lines to cross at a 90-degree angle. Parallel forces the two lines to have the same orientation in space. And equal forces the two lines to always have the same length. Let's apply the perpendicular relation here. Now, we've applied all of the relevant geometric relations to our triangle, but it's still not fully defined. We're going to need to add some numbers to describe this thing. Enter the Smart Dimension tool. This is going to be one of the most common tools that you use in sketches, as it allows you to define lengths, distances, and angles. First, I want to define our horizontal line. I want this edge to be 50 units long. With our tool selected, we can left-click on the horizontal line, and then left-click to place our dimension, and then type in our desired value in the pop-up box. We can see now that our right endpoint is also fully defined. It's gone from blue to black. This is showing us that this bottom edge has only one way that it can be interpreted. It's a horizontal line that goes 50 units to the right, and it has its left point starting at the origin. One down, two more to go. We can also define angles using the Smart Dimension tool. When you have two non-parallel lines, you can select them both via left-clicking, and then select one more time to place the dimension. Another option, particularly powerful with arcs, is that we can use 3 points to define our angles. With the tool active, we can trace out an imaginary triangle by going from extent to center point to extent, and then left-click once more to place our dimension. It's always important that you're keeping track of the blue guidelines, which show us exactly how the dimension is being measured. In any case, I want the original angle for our triangle to be set to 60 degrees, so we can left-click on the number of the dimension, type in our desired value, hit enter, and we get our fully defined triangle. Of course, there are plenty of ways to fully define a triangle, so let's take a look at another. Maybe I want to define two side lengths and their shared angle, instead of two angles and a side. I'm going to delete this perpendicular relation over here, and then we're going to set the side length of this edge here. With the Smart Dimension tool active, we can left-click on the line, and then we see that this isn't as easy as we had hoped it would be. While we're close to the line, the tool allows me to define the length, but if I move horizontally away from the line, it allows me to define the height, while moving vertically allows me to define the width. Each of these three measurements is different, so it's important that you always measure the distance the way that it's shown in the drawing. As a final note, you can also use the Smart Dimension tool to define the distance between 2 points or two parallel edges. And it also functions to allow you to define the diameter or radius of a circle. For this circle, if we attempt to define its radius, we can see that it defaults to giving us the diameter. If you intend to define the radius but it defaults to the diameter, or vice versa, we can set our dimension, left-click on the leader without the Smart Dimension tool active, and then pop over to the Leaders tab of the Dimensions sidebar. From here we can choose between radius and diameter to define how the dimension is displayed. This menu also has some options to allow us to define distances between circles and arcs. By default, measuring the distance between two circles is going to go from center to center. But if we check the menu, we can see that it also allows us to define the distance from inner edge to inner edge, outer edge to outer edge, or any combination of the two. In any case, let's return to the triangle as it was defined earlier and get back on track. So, as I had mentioned before, it's important to fully define our sketches. So there are 3 ways to tell if a sketch is underdefined. The first is that not everything in the sketch will be black. Due to the line quirk that I had mentioned earlier, the endpoints of center lines are allowed to remain blue, while still having the sketch be fully defined, but the edges of construction geometry and center lines do need to be black. The second way to tell if something in your sketch is underdefined is through this text down here. If we were to undo to add back our deleted relation, we can see that it changes to fully defined. Third, when you exit your sketch, it will have a little minus sign next to it. Your goal for this course is to make sure that all of your sketches are fully defined. So before you turn in any assignments, make sure to check each sketch to make sure that there are no minus signs, as each one will cost you points on your assignment. There are several more relations that show up frequently. A complete table is available in the lab chapter, and it goes over what each relation does and how it's used, but here are a couple of my favorites. The tangent relation enforces a smooth connection between an arc and an edge, matching up their first derivatives if you're mathematically minded. Concentric is going to force two circles or arcs to share the same center point, and coradial acts as concentric, but it also ensures that the two arcs have the same radius. These are not all of the relations. There are plenty more to go over, but I don't want this video to get too long. A lot of relations are based on design intent. For example, there's a difference between drawing this, a square where we've defined both sides to be 50 units long or tall, respectively, and drawing this, a square where we specified that one of our sides is 50 units long, and the other side is of equal length to the first side. In one circumstance, if we change the width from say 50 to 30, the height remains the same, whereas in the other one, if the dimension's been changed, all of the edges are changed to match. Now, for a few guidelines on how to approach sketches. First, you're going to want to draw your basic shape or outline. This is going to be done mostly by eyeballing, and you'll want to make sure that you have every line and arc, but they don't need to be exact. Next, you will want to add in any of the relations that didn't get added automatically. The last step is adding in all of your dimensions, which should fully define the sketch. If anything is underdefined, left-click drag on the blue components to figure out how they can move, as that often reveals some additional geometric relations that you might have missed in step 2. The exact ordering of dimensions and geometric relations can be a little bit more of an art than a science, but I find that order tends to function fairly well. Of importance, make sure that you use all of the dimensions that you're given the number of times that they're given, in the form that they're given to you in. Do not calculate any dimensions, do not repeat any dimensions, and do not skip any dimensions. Each dimension is an important part of the designer's intent, and acts as a control knob to modify the part. Leaving a dimension out of the model removes that control knob. Repeating dimensions also ignores design intent, as it makes it so that future engineers will have to update multiple dimensions in order to get the intended change, not just one. Calculating dimensions means that any future changes must also be calculated, leading to more work for future users, while also leaving the door open for avoidable mistakes. All of these offenses are considered poor design practice, and a full list of tactics to avoid is available on the website. That covers everything that I had to talk about for today. Have a good day. We will see you again next time.